so this might be a bit silly to show you in such detail, but I thought it couldn't hurt. I've only got a Spectrum setup, not Futaba, and this is just a rubbishy AR6110E receiver, but maybe just a sort of long-winded procedure might help you spot something that you're missing, because otherwise it's going to take so long to talk through all the possibilities. So let's start with aileron. I'll plug a servo into aileron. It's actually quite quick, by the way, this, you'd be surprised. So there's the aileron servo. If I now move the aileron stick, I'm getting movement on the servo, so I know that that marked aileron is correctly marked, and I'll take a microbeast lead and plug it onto aileron, observing obviously negative pin to the top, signal at the bottom. Take that aileron cable, pop it into the one marked aileron, and the microbeast turns on. But it won't initialize properly because there's other things to do yet. So taking our servo again, this time I'll pop it into elevator and check that we get movement. So that's now elevator, as you can see. So take that cable out, pop in your microbeast lead, the second of the single leads, and pop that into the one marked elevator slash DI1, I think. So that's that wired up. And then going back to your servo again, next one we've got coming up is rudder. So pop on the servo, go to your rudder stick. As you can see, I've got movement there. Remove the servo and pop on the orange wire, which is the rudder signal cable. And this time the single cable is at the bottom where the signal is marked, signal pin on the receiver there. I know this is a bit basic, but I'm sorry, because I'm confused as to what your issue could be. Servo again, this time to gear, which will be gain, because I'm going to assign the gain to it. At the moment I haven't assigned it in the radio, so the only thing I can do is use the gear switch to move the servo, but as you can see, the gear switch does indeed move the servo. So once I've assigned gear to gyro, I'll be able to use the gyro menu to change that, and then just pop that on there. And then finally this is the red lead, which is pitch. So if I put a servo onto AUX1, you can see now when I move, change the pitch on the radio or the collective, the servo moves, so that must be right. So I can put the red lead on. If I then take that triple output input cable and pop it into the microbeast into AUX pit RUD, you can see that the microbeast has now started to behave a bit more correctly. It's stopped flashing and it's saying it's in HH mode because it's blue. If I flick the gear switch, you can see I can change it to, I can make the lights flash and change gain, blue to, from heading hole to red mode, etc. So it's kind of working now, but we haven't done any setup stuff. So because we've just been plugging things in live, I'll just turn it off now. Probably not the best way to do it, plugging things in live, but at least you can see it move along. I'll pop in the cyclic servos, 1, 2, quickly blasting through the menu items. A for mounting orientation is on blue for standard. B, which is swash plate servos frequency, which is on 50 Hz standard default setting. C is pulse width for the tail servo, I think. D is the frequency on purple, 50 Hz again for this cheapo servo. E is for endpoints, which you move with the rudder stick, and as you can see, as I move the rudder stick I can control the endpoints, so you go all the way to the left until it just binds and then back it off a tad, and then you'll see the microbeast flash, and then you go the other way until it binds and just back it off a tad, and then you'll see the microbeast flash to denote that it's detected that. So that's your endpoint set. Next one is sensor direction, so if I yaw the microbeast, you can see there, once it's on red it kind of follows what I'm doing. If I push the rudder stick, it goes to blue, it now does the opposite of what I'm doing. Push the rudder stick again, goes to red, now it goes with me. So that's how you adjust that one. G, this is the 3 cyclic servo squaring up step, so press the rudder once, one of them twitches, it was this one, adjust it with the elevator till it's perfectly square, not really but good enough. Press it again, another one twitches, it was this one this time, adjust with your rudder, elevator sorry, until it's square. Press the rudder again, jumps to the next one, which is this one. So far out on the spline I can't quite get that square with the elevator, but assume that to be right. Press the rudder to move on. You've now gone back to the far off reference positions, because I was very slipshod with that, and then press it once more and they're all at the nice square positions. So that's how you would do step G. Once they're all set with the light on like that, you do your links to your swash, get your swash level, and then you do the long links to the head to get the blades at 0 degrees. Then H, what is H? Can't think. Red, yeah, swash plate geometry. I did try to look at my little crib sheet, but it's all worn out in the middle there. Swash plate geometry, I think, so it's like 120 degrees is red, so that's typical arrangement. I is probably how you make them all move in the same direction. You know, all up or down when you move the collective. J, that's where you would set your 6 degrees, so your 2 aileron servos, which are these two, are going to move, and then you hold the aileron over, push it over, sorry, you can give it tiny little taps. When you've got it reading exactly 6 degrees, you stop and press to move on. K, collective limit, you go to your full collective and adjust it with rudder. As you can see, they move there, all of them in fact, because it's collective. So you set your high and your low, do the same with low, set it to how you want, and that now gives you a full range of collective. L, limit, swirl your cyclic and check for binding. If there is some binding, you can reduce it with the rudder. You can see I've reduced it right down now, they're barely moving. And if I put it in the corner and watch them move as I push the rudder to accelerated correction motions. You can see the not half moving there while I'm moving the microbeat. That's far more aggressive than the corrections would be in flight mode. And then lastly, it's N, and N is like when you yaw the helicopter and watch to make sure the swash plate stays in the same orientation in space. So in other words, the swash plate will stay at one angle and you can kind of whiz the helicopter around it without it moving. And that's it, that's the whole thing.